Understanding the various aspects associated with performance, stability, and control, and their associated indication on cockpit displays has become a key aspect in improving crew awareness. In this video, we will discuss some of these indications and what is behind the symbols you are used to seeing during flight. Just to recall some aerodynamic concepts. The lift force generated on a surface is a result of its angle of attack, the dynamic pressure of the air moving around it, which is a function of the airspeed and air density, and the size and shape of the surface. Lift varies with angle of attack, for constant speed, and air density. As the angle of attack increases, lift increases proportionally. However, at the critical angle of attack, lift decreases instead of increasing. When air moving over the upper wing surface can no longer remain attached to the surface, the flow breaks down. This is stall. Remember that the angle of attack is the angle between the relative wind and the chord line of the airfoil, which should not be confused with the flight path angle or the pitch attitude. Pitch attitude is the angle between the longitudinal axis of the aircraft and the horizon, as displayed on the EADI. The angle of attack is the difference between pitch attitude and flight path angle. The flight path angle is the angle between the flight path and the horizon. An airplane can stall at any attitude and airspeed, as you can see in this animated video. The pitch angle is sometimes negative, very steep, and yet the aircraft may be in a stall condition. It is not always easy for the pilot to recognize such situation and take the necessary action to reduce angle of attack. The green dot is a solid grain spot next to the speed tape on the PFD. Simply put, it is an indication of at least 1.3 G margin over the shaker speed. That is, you may reach a 40-degree bank angle till the shaker is activated. The green dot value is derived from an equation that uses the gross weight produced by the FMS, altitude, and lift coefficient. Lift is based on airspeed in Mach, which is converted into indicated airspeed to be displayed in the PFD, and slat flap position. Observe that bank angle or angle of attack variables are not taken into account. Thus, do not expect the green dot to change its position if you vary angle of attack or roll attitude. As we have just mentioned, the green dot depends on the aircraft speed. During cruise flight, if for any circumstance you allow the airspeed to drop, typically after an engine shutdown and a subsequent drift-down descent, you will see the green dot dropping as well till it matches the aircraft's airspeed. Confirm it by checking in the chart what we mean. This is a plot of the green dot as a function of Mach number and indicated airspeed. It is apparent that as the aircraft speed in Mach decreases, both indicated airspeed and green dot decrease as well, till a point they cross and become equal, exactly as you can see in the PFD. This point corresponds to the drift-down speed. The drift-down speed defined by the ECA-FM, and therefore by the green dot, is actually a compromise between a proper lift-drag ratio and a speed margin of 1.3 G over the stick shaker speed. Therefore, at the green dot speed, you have a 40-degree bank margin before the shaker activates. The green dot may be displayed or not during all airborne phases of flight, as a result of the variables taken into account to calculate the spot, even though it is not designed to provide pilot guidance except for drift down and flap extension. In normal wing-level cruise flight, the green dot just indicates a margin of at least 1.3 G over the stick shaker speed. In icing conditions, it is recommended to use green dot plus 10 knots, as the green dot equation does not account for icing effects. The green dot will not change its position after speed brakes have been deployed. In this case, the 1.3 G margin and the lift-over-drag ratio is not applicable anymore, as some lift is removed from the wing and drag is added. During the normal slow-down to approach speeds, the green dot will get you the appropriate flap extension speed. The dot will not be displayed during flap transition, but it will come back when the new configuration is established. If the pilot wishes to reduce to a speed below the present green dot, then more flap should be selected. When flaps 5 or full is selected for landing, the VREF may be slightly greater or less than the green dot. It is perfectly normal and depends on the certification, engine installation, and flap setting. Check some plots for the Embraer 170 and 190. Also check it for some special conditions such as a steep approach and then a Cat 2 landing. Moreover, you can use the green dot as a reference for holding speeds, except in icing conditions. Check these additional plots for various weights, altitudes, and different E-jets. When superimposing the green dot curve, you will see that they are nearly the same. This is due to the fact that the published holding speeds take into account approximately the same 1.3 G maneuver margin, an LD used by the green dot. The low speed awareness tape is the stall speed warning and caution ranges displayed on the PFD. The tape will rise from the bottom of the airspeed scale. Red and amber ranges are defined according to the depicted table. The low speed awareness tape turns amber from the stall speed, multiplied by a K factor, down to a stick shaker speed. It is read at or below the shaker firing speed. The K factor depends on the airspeed and varies between 1.13 and 1.054. Flying within the amber range means flying close to the stick shaker speed. Reaching the top of the red range means that the shaker is activated. The amber and red ranges are based on airspeed, aircraft flap slat position, and angle of attack. They will also vary if the aircraft enters icing conditions, that is, ice is detected and the associated messages are displayed on the ICAS. However, there are a few exceptions in this ice logic. 1. The low-speed awareness bar red and amber ranges will show the same indication for flaps 4 and 5. And this is applicable for either the 170 or 190 fleet. And 2, on the 17 fleet only, the low-speed awareness bar is not affected for the icing effect when flap 0 or 1 is selected. Speed brakes used in flight will make the low-speed awareness bar raise on the speed scale, clearly showing how stall speed increases. The effect is proportional to speed brake surface deployment. The greater the surface deployment, the greater the amber and red ranges raise. The pitch limit indicator is a representation of the margin, in degrees, between stick shaker and speed and current airspeed, using the aircraft symbol as a 0-degree base. The scale is the same as the pitch scale. It is based on angle of attack, airspeed, and flap slat position, the same used by the low-speed awareness tape. Color code is dependent on airspeed. The PLI is displayed when flying below 1.2 times the 1G stall speed. It becomes green, amber, or red according to the depicted table. Flying in the amber pitch limit indicator means flying close to the firing angle for shaker activation. A red pitch limit indicator means that the shaker is activated. It is important to emphasize that flying with a green pitch limit indicator is a perfectly normal condition. Now it is time to show how it works when airborne. See how the pitch limit indicator varies with speed. It is quite the same curve used by low speed awareness equation, as pitch limit indicator and low speed awareness use the same input to draw the data on the PFD. As an indication of the stall angle, the pitch limit indicator will react to ice detection and speed brake deployment, exactly as seen in the low speed awareness bar. Check it in the video. On the head-up display, the green dot is a hollow green spot. The low speed awareness ranges are represented by different drawing patterns. The pitch limit indicator becomes an angle of attack limit indication, and its symbology is fairly different. Check the symbol. It moves towards the flight path symbol, so that when it is positioned at the flight path symbol, the aircraft is at the stick shaker firing angle. The logic behind the green dot and low speed awareness indications on the head-up display is an exact repetition of what is displayed on the PFDs. Regarding the angle of attack limit on the head-up display, it will show consistent indication, as its basic reference is not the aircraft pitch, but rather the flight path symbol. Let's consider an Embraer 190 flying at 41,000 feet, 35,500 kilograms, Mach 0.78. The PFD airspeed tape will indicate that the aircraft speed is 230 knots. The green dot will be positioned at 212 knots, and the top part of the low speed awareness amber range will be positioned around 195 knots. Now let's check how these indications show up when the airspeed reduces to Mach 0.68. Set the airspeed bug to Mach 0.68 and notice that it will be positioned below the green dot and close to the low speed awareness amber range. This may create the idea that the airplane would have little margin to maneuver at Mach 0.68. However, as the airspeed reduces, these indications will start to move below the aircraft target speed. Notice that the pitch limit indicator green indication will be displayed when the airspeed reaches 206 knots. When the aircraft reaches Mach 0.68, the airspeed will indicate 1.98 knots. The green dot will be positioned at about 198 knots, and the top part of the low speed awareness amber will be positioned at about 182 knots. Now the low speed awareness red region will be displayed at about 172 knots. Thus, at Mach 0.68, the airplane has just 1.3 G margin as it is flying over the green dot. Considering the previous scenario, let's consider an engine failure at Mach 0.75 and check how these indications change during drift down. The Embraer SUP-M procedure for engine failure requires the crew to configure the aircraft for drift down and reduce the aircraft speed to the drift down speed, represented by the green dot. As the aircraft speed is reduced, the green dot speed is also reduced, but at a smaller rate. When the indicated airspeed matches the green dot, the airplane will be flying at the drift down speed. This is the point when the descent should be initiated. During the descent, the crew should monitor the green dot speed and adjust the aircraft speed as required to match it until the aircraft reaches the one-engine inoperative level-off altitude. Now take a look at the low speed awareness, pitch limit indicator, and the green dot when the airplane banks. As mentioned earlier, the green dot logic does not take into account the aircraft angle of attack, but the low speed awareness and pitch limit indicator do. Thus, when the airplane banks 30 degrees, keeping the same airspeed and altitude, the green dot position will not change. However, the low speed awareness will move upwards and the pitch limit indicator will move downwards. The increase in load caused by the turn uses the upper part of the margin that is available during the accelerated 1G flight. Since bank angles greater than 30 degrees are not normally used during turns, there is an additional overbank margin of 10 degrees when a 1.3G margin is available. This is evident as the low speed awareness tape climbs closer to the airplane speed, as the load increases during the turn. This is normal. Turbulence, like turning, causes increase in load. Therefore, the combination of turning and turbulence will use up more margin than when in smooth air. Therefore, when maneuvering during approach in turbulent conditions, the pilot may wish to operate at a speed slightly higher than the green dot, but below maximum flap extended speed, VFE. Let's see how it does when the aircraft enters icing conditions. Remember that the green dot logic does not take into account icing conditions, but the low speed awareness and pitch limit indicator do. Thus, when icing is detected, the green dot's position will not change. In this case, the Embraer SOP-M recommends to fly green dot plus 10 knots to maintain the 1.3G margin from the stick shaker speed. The low speed awareness will suddenly move upwards, and the pitch limit indicator will suddenly move downwards, indicating that the maneuver margin has been reduced.